Welcome to question 10 of the 2007 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So we know that the area of the region bounded by the curve with equation y equals kx to the power of a half, where k is a positive constant, the x-axis and the line with the equation x equals 9 is 27. Find k. So to start with, we're just going to sketch a graph of what this situation is describing. So this is the x-axis and the y-axis, and the equation y equals kx to the power of a half is just a square root graph, so it would look something like this. And bounded by that curve, the x-axis and the line x equals 9 has an area, so if I shade that area in, that area is equal to 27. So to find the area under that curve, we can use integration and go between the lower limit, which would be here at 0, up until an upper limit of 9, for the equation kx to the power of a half with respect to x, and we know that's going to equal 27. Therefore, we can evaluate this as the antiderivative, so this would be kx, and we add 1 to the power, which would go from a half to 3 on 2, and then divide by the new power of 3 on 2, and we evaluate that between the terminals 0 and 9, and that would still equal 27. And then if we just clean this up, that would be kx to the power of 3 on 2 divided by 3 on 2 would be the same as 2kx to the power of 3 on 2, all divided by 3. So instead of dividing by a fraction, we multiply by its reciprocal between the terminals of 0 and 9, and that is again still equal to 27. And we know this can be evaluated as the antiderivative at 9, subtract away the antiderivative when x is 0, and that should equal 27. Therefore, we have 2k times 9 to the power of 3 over 2 divided by 3 minus 2k times 0 to the power of 3 over 2 divided by 3 is equal to 27. And now the reason why we've put 9 to the power of 3 on 2 in purple is because that is something that we need to know how to evaluate. So I can rewrite that as 9 to the power of a half to the power of 3. And 9 to the power of a half is the same as the square root of 9, which is 3 to the power of 3, which equals 27. So therefore, we find that 2k times 27 divided by 3 minus 2k times 0 to the power of 3 on 2 minus 3 is simply 0 is equal to 27. Therefore, we find 2 times 27 over 3 is equal to just 2 times 9 is 18k equals 27. Therefore, k equals 27 divided by 18, which simplifies to 3 over 2. So that is the value for k, such that this question has an area of 27 under the curve between 0 and 9. So the examiner's report says that this question was generally well answered, with a third of students getting full marks. Many students were able to set up a correct expression and integrate correctly. However, 1 divided by 3 over 2, so when we divide by the new power, sometimes became 3 over 2 instead of the reciprocal 2 over 3. Too many students were unable to evaluate the expression 9 to the power of 3 over 2 correctly. So that's what we did in the purple on the previous slide. Some students had little to no idea and simply set up the given expression equal to 27, and another common incorrect expression was shown here to be between 0 and 9 of kx to the power of a half minus 9 dx equals 27, where they were confusing the line x equals 9 with the line y equals 9.